um, populating a little database for another project I'm working on. Oh, probably got another 35-40 minutes to go on that. Let's clean up some things from some of the previous days here. So let's take a look. Day 1 was good. Day 2 looks good. Day 3 looking good. Day 3 was fun. What was this one again? Oh yeah, I was finding the Xmas. Let me check the test for that one. Okay. Day 5. Day 5 was cool. 6. Tests are there. Oh, we're lagging. I really want to turn this off. Oh, this one was fun. That was like where you're simulating the guard. Where my tests in for that? Oh yeah. 7. Yeah. 7's good. And the tests are in. 8. Oh yeah, that was with the antennas. That was cool. 9. This is... I could clean this up. Do I have my tests in for this one? Yeah. So I think I could clean this part up. I'm using a... Ugh. I'll come back to that one if I need to. I know there's some ones that I really need to prefix. What was 10 again? Score, sum, DFS. Oh, this was the hiking trails one. This one was fun. Day 11. Oh yeah, that was with the blinks. How did I end up solving the part 2? Just dynamic programming. Oh yeah, what is that? Oh, why did I call that thing? Split digits in half. What's a better name for that? Let's see. 10 to the power of num digits divided by 2. What is that actually? So you get the number of digits. Yeah. Did I have my tests in for 11? No. Was this one able to solve both sides? I think I had something weird with I did this one a little. Wait, why doesn't this? Actually, why is that mad? Oh, because it takes longs now. Or it returns a long. And if I remember correctly, something was weird. Day 11. What was the expected sample? Yeah, I wasn't given an answer for that one. I mean, I could just throw this in there. This was the right answer. But that was for the actual input. Well, I can double check that it returns that still. Oops, see what happened. Null pointer. So how are we getting a null pointer? Sample is not in there. That'll do it. It's just the... Yeah, here's your sample. Well, I guess I don't need to do that. Oh, right. Let's just do this. I don't have at before each. Okay. And I can just double check that I'm giving the same output. 6220. Yeah, okay. Just to kind of like make it a promise in case I want to refactor it. We know my code is correct, so I'm just gonna use the sample. Sample's just smaller, that's the only thing about it, so yeah, obviously you don't want to do this in like a practical setting. But like I said, I'm just kind of doing this to make sure that if I do refactor it, make sure everything stays the same. And they didn't give me a sample for part 2, so obviously it's gonna pass. Okay. And how did day 11 look? I think it looked pretty clean. Yeah, day 11 looked good. Day 12 was super nasty. I need to come up with a better way to what was this one for again? Oh yeah. The regions. So definitely need to come back to that one, and I probably didn't finish my test for that either. Okay, yeah I did. So day 12. I'll put in a to-do. Clean that up. I'll put a to-do over here in 9 also. To clean. I feel like there's a better way to do this. I think there's a better way to do this whole problem. It was brute force. Clean this up. Let's look at day 13. What was this one again? Oh yeah, we use system of linear equations. I think you could yeah. And this one's not bad. Not too bad. And day 13. What's wrong with that? Oh, long. 3 minutes. And there really wasn't a sample for that one either, was there? I don't believe so. So same thing. Let me make sure I'm getting that same output there. $13. $908. Oh? Oh. Wait. Oh yeah. Zero zero 470. Okay. And then we'll just run the sample again. Same thing, just kind of a promise here. In case I want to refactor that. It's obviously going to pass. I produced that output. Okay. Day 14. There really was not a way to test part 2 for this one. So, not the way that I did it anyway. Okay, so I guess I need to have that, but I'll just leave it empty. Almost time. Yeah. All right. Here we go. 30 seconds. $15. $10 seconds. So I've already made it farther this year than I did last year. That's cool. Alright, let's see what it is. Okay. You appear back inside your own mini submarine. Sweet. Each historian drives their mini submarine in a different direction. Maybe the chief has his own submarine down there, or down here somewhere as well. Oh yeah, we're looking for the chief, right? I forgot about that. You look up to see a vast school of lanternfish swimming past you. On closer inspection, they seem quite anxious, so you drive your mini submarine over to see if you can help. Because lanternfish populations grow rapidly, this sounds kind of maybe cellular automata problem or something. They need a lot of food, and that food needs to be stored somewhere. Oh, maybe not. That's why these lanternfish have built elaborate warehouse complexes operated by robots. These lanternfish seem so anxious because they have lost control of the robot that operates one of their most important warehouses. It is currently running amok, pushing around boxes in the warehouse with no regard for lanternfish logistics or lanternfish inventory management strategies. Right now, none of the lanternfish are brave enough to swim up to an unpredictable robot so they could shut it off. However, if you could anticipate the robot's movements, maybe they could find a safe position. The lanternfish already have a map of the warehouse and a list of movements the robots will attempt to make. Your puzzle input. The problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict. Okay. Oh wow. Is the robot's the @ symbol attempts to move. If there are any boxes, 0 in the way, the robot will also attempt to push those boxes However, if this action would cause the robot or box to move into a wall, nothing moves instead, including the robot. The initial positions of these are shown on the map at the top of the document the lanternfish gave you. The rest of the document describes the moves, that for up, down, left, right, that the robot will attempt to make in order. The moves form a single giant sequence. They are broken into multiple lines just to make copy pasting easier. New lines within the move sequence should be ignored. Here's a smaller example to get started. Okay. Were the robot to attempt the given sequence of moves, it would push around the boxes as follows. So, no move. We go up. We go up. We go up, but no move. We go to the right. The boxes get pushed. Oh boy. We go to the right, nothing happens. We go down. We go down again. Can't move. Then we go left. Go down. Right, pushing a box. Right again, can't move. And down. Yeah. The larger example has many more moves. After the robot has finished those moves, the warehouse should look like this. Okay. The lanternfish use their own custom goods positioning system, GPS for short, to track the locations of the boxes. The GPS coordinate of a box is equal to 100 times its distance from the top edge of the map, plus its distance from the left edge of the map. This process does not stop at wall tiles. Measure all the way to the edges of the map. So the box shown below has a distance of 1 from the top edge of the map and 4 from the left edge, resulting in a GPS coordinate of 100 times 1 plus 4. Okay. The lanternfish would like to know the sum of all boxes' GPS coordinates after the robot's finished moving. In the larger example, the sum of all the boxes' GPS coordinates is 10092. Smaller examples, 2028. Predict the motion of the robot and boxes in the warehouse after the robot's finished moving. What is the sum of all the GPS coordinates? Okay. I think I'm just going to simulate the robot's movement. And the box part's going to get tricky. What did I say the larger example was? 10092. Is our thing done? 70%. Okay. Okay. Day 15. And I would bet that the real output's going to be big today. Probably going to be kind of large. Okay. All right. Okay. So just gonna simulate the robot's movement, and I think when I hit a box, I'll just like recur. Oh, why am I failing at test 14 on day 14? Well, let's just not worry about it right now. Dang, I'm lagging hard. Okay. So let's think about this. Why don't I go ahead and parse my data first. How should I do this actually? So if the robot moves, if there's a box colliding with the robot, or if there's a box touching the robot, and the robot moves in the direction of that box, let's move that box first. So we'll apply whatever method I write to the box to move in that direction. And if that box is touching another box, same thing, apply that direction, move that box in that direction, and then once we move that box, we just like backtrack, move forward, or if nothing moved, then we don't move. Yeah. So the box pushing thing, I'll do a little bit of recursion, I think. Yeah. Let's parse the grid first. Let's do that. So how did that data look? Split it by a double new line. Is that what that is? Yeah, it's a single new line, or single blank line there. So let's do that. How should I do the directions? Maybe just well, I know the grids. I'm just gonna do it as a character grid. And it's gonna have a number of rows and a number of columns. Should do the directions as a stack. Sure, why not? Yeah. And I think I have a utility for the other thing. Equals parser style. char matrix, map data, and split that by a double new line. And map data is going to be the first part, and the direction data is going to be the second part. I really should or should I just do it as a list? It'll be a little more general that way. I don't need to have a stack. So I'll just make a utility for that real quick. Parsers. I could make this... nah. Maybe not. Well... dot map. Is there a map to... I could map it... Actually, it's already ready, right? It's already a stream of characters. Am I right? No. Oh. Stream of integers, that's right. Just do this. Is that possible? How the heck do you turn a string to a character again? I know I have the chair at, but is there another way? Oh, that's right. Yeah, I'm a goofball. I need to get rid of the new lines too, so... yeah, this won't be really generalized because those new lines in there. I don't really need to have a util for that then. So it's really just going to be... Oh, come on. Is this almost done? It's going to be data parts 1 dot replace all of these. Oh, that's why it looked like that. Replace all of those with nothing. And it's a regular expression, so yeah. Yeah, I'll just make it a character array. Oh, that's... Okay. And let's just print those out real quick. Okay. Oh. That doesn't look right. What's up with that? Eh? Oh my gosh. I Control Z'd that thing off of there. Okay. That seems right. Cool. All right. Let's get the position of the robot. Okay. So we're going to get the robot's position. now that we have the directions, let's simulate the movements with the directions. And first we want to find the robot. Find robot equals and then for each direction I've been writing in like 3 other languages today. For each direction, let's move the robot. Now move, I think I'm gonna do it as a Boolean recursive thing. And we're gonna take the position and the direction. And is there always going to be there's always going to be walls around the edge, I'm assuming. I'm assuming so. So if the one in front of us is a wall, that's going to be our base case. So I should do this. Yeah. Would be a better way. Yeah. We're gonna put up, down, left, right. So up is gonna be mapped to up, down, left, right. So up, down, left, right. Up, down, left, right. Really should have those somewhere in like a utility. So that's going to map to up, down. Is it a capital V? Probably. Yeah. Down. Left. Right. Okay. So for each direction, we're going to move the robot, which is at IJ in this context, in that direction. And while we're moving, this could be a recursive thing. So my base case is going to be if grid. First, let's get the direction. Let's do this. And if grid I plus, why don't I do this? Next I equals I plus did. Next j equals j plus dj d. And if grid next I next j is a wall, then return false. I guess. And then the first thing we want to do is move the guy in front of us, and then we'll move ourselves if the guy in front of us moved. So if move the guy in front of us, which is next I, next j, in that same direction, let's move ourselves. Oh. I think this will work. So if the next guy was able to move, then we just want to swap, right? Is this gonna work? I think so. I haven't thought too hard about it yet. Well, you really don't need to do that. You can just set the, you don't need to do all that. You could just say grid next I, next j equals grid ij, and then grid ij equals period for an empty spot. And I think that probably might work. I don't know, this doesn't seem right actually. Move in that direction, and then what do you do after that? That's all you gotta do for simulate movement. So let's see if we get like Stack Overflow. Let's see if something happens. What? Huh? Let me see those directions again. Oh, those are little V's, huh? something happened. That looks the same as the input dough. Does it not? Yeah, it definitely didn't work. Is that not the same as the input? No, it's not. Oh wait, that's the wrong example. Where's the big one? Yeah, that's the same as the input. Okay, something didn't work. Okay. Okay. So let's see here. Up, down, left, right. Up, down, left, right. And if the one in front of us is this where we're ending up every time? Let's just see where we're ending up. I think I should maybe I should return true out here. No? Let's just see real quick. Where are we? Getting stuck. Oh, it's like every time. So it should be the robot. Oh, you know what we're not doing? We're not updating the robot, the freaking robot position. What if I just... Let's make those... I don't know about doing that. Let's just do it for now. Or what if I just... I don't have a better idea right now, so let's just make it really slow and get the position again every time. Not a good idea, but... crap. Still the same. Okay, every time that's happening. How the heck is that happening? What? Are these changing? Surely, right? No, it's not changing. Well, the robots doesn't even start. Doesn't even start there. Let's just do this because we know exactly where it starts. There should be a O. Oh, wait. Oh, you know what? Oh, I'm not handling if it's a period. Is it moving at least once? So if it's that, return false. If move next one, the next one. Yeah, I'm not, yeah, let's do this. Maybe. Oh, I just put that in there, yeah. If grid if it equals a period or the next guy was able to move. Okay. That looks right. I think I did it. Sweet. So now I need to... What do I need to do? The sum of all the box coordinates, which is 100 times the distance from the top plus the distance from the left. Okay. And if it's a what is that? Is that a O? If it's a box, then we say chord sum plus equals the distance from the top which will just actually be the row, right? Should be I times 100 times I plus J, right? Isn't that it? Simulate those bad boys and then return the return that, and that should give me this. Sweet. Where am I printing? Alright, let's do it with the big one now. and then see what kind of wrench they throw in this plan. Ah. 15. This is the real one. Seems reasonable. Yay. The lanternfish use your information to find a safe moment to swim in and turn off the malfunctioning robot. Just as they start preparing a festival in your honor, reports start coming in that a second warehouse's robot is also malfunctioning. This warehouse's layout is surprisingly similar to the one you just helped. There's one key difference. Everything except the robot is twice as wide. Okay. The robot's list of movements doesn't change. Alright. You get the wider warehouse's map. Start with your original map, and for each tile, make the following changes. If it's a wall, it's now going to contain 2 walls. Like this though. So not like this. If the tile's a box, the map now contains a couple of brackets. If the tile is a period, replace it with 2 periods. If the tile is the @ symbol, it's just gonna have another period behind it. Okay, not too hard, just using string replace. And then what's after that? Oh, it's gonna change how our movement works though too. Because the boxes are now twice as wide but the robot's still the same size and speed, the boxes can now be aligned such that they now be aligned such that they directly push 2 other boxes at once. Wait, what? It's still the same size and speed. Boxes can be aligned such that they directly push 2 other boxes at once. What do you mean? Could they not do that before? I see. Oh, crap. Yep, really threw a wrench in there. So. Oh, man. This warehouse also uses GPS to locate. For these larger boxes, distances are measured from the edge of the map to the closest edge. From the edge of the map to the closest edge of the box in question. So the box shown below has a distance of 1 from the top of the edge of the map. And oh man, they've really changed it. Okay. Okay, let's resize the grid. Let's think if I even want to represent it like that. I think I'll have to, because now 1 box can be in contact with 2 boxes. And how would my movement logic work now? Oh, and the robot could also push 2 boxes at once, right? right? Or no? Oh, no. No. Just the box. The box can push 2 boxes at once. Interesting. But only when it's going up, right? Yeah, only when we're moving up or down can it be in contact with 2 other boxes. Mm-hmm. And oh yeah. All right, let's see what we can do. Let's just like copy paste for now. And okay, so this is going to be different now. Maybe I should make another method to move a box. So we're gonna get the next eye. Just assume that we're at a robot right now. And let's just like separate this by case first. I don't have a better idea yet. If D is up or down. So if it's up or down, that's when we got to worry about being in contact with 2 boxes. But if we're going left or right, you can really just treat those boxes as 2 separate boxes, just like before, if we're going left or right. Yeah. Right. I think. So if we're going up or down, we got to worry about a box being in contact with 2 boxes. But if we're going left or right, we don't need to do anything special compared to the first part. Yeah. Mm-hmm. Okay. But if we're going up or down, if we're going up or down, why don't I do this? This will clean it up. No, not that one. Oh wait, yeah. So this will be next. Okay. So if next is this could actually Just wait a second. This could be outside, actually. If next is a wall, same still applies. That applies for all cases. Am I gonna separate those into two separate recursive calls? No, I don't think I'm gonna do that. So if we're going up or down, and let's say if next is left bracket, we're going to do something. If next is a right bracket, we're gonna like do something, I guess. So we're going up or down, right? Ugh, how is this going to work? I guess I could have another method for move big box. And this will take 2 positions. Okay, we'll just assume that I have that implemented for now. What if, can I put these together maybe? If it's that or that. So for going up or down, I can actually probably just put all that together in one condition, right? If we're going up or down, and the next piece is a big box, or it's part of a big box, then we're gonna return move big box. Oh, kind of do need to know. Yeah, back up a little bit. Won't put that in there then. So if we're going up or down, and the next one is the piece of a big box. Then we know the other side of the box is to the right of it. So move big box. That's going to be next I, next J, next I, next J plus 1. Right? Else if Next is this side of a box. Move big box. Next I, next J. Next I, next J -1. Okay. But what if we're going up or down? Okay. So if we're going up or down, and the next cell is the left part of a box, then move the big box. Oh wait, what if we're pointing down? Oh, that's always gonna be to the right of it. Yeah, that part doesn't matter. Yeah. Yeah. And if the next position is a period, or we were able to move. Oh wait. If move big box. If the big box was able to move, then just is that missing something? Totally. If that big box moves, do this. If this big box moves, then we know the piece in front of us has cleared. Do that. Yeah, it's getting ugly. Return true. If anything else, if the next one's open, or we're able to move the next one, this would be just, it's not a big box. Or it's a big box that's moving in the left or right direction. Oh, crap. Because what if we're moving up? You gotta move the... You gotta move the other piece of the big box with you. Oh, dude. Yeah, this one got kind of tricky. So if the... Yeah, like if we're moving to the left. Oh, we're always following the robot though. Yeah, we're always following the robot, so that should work. That should still work. But what if this current one, if we're going up or down, I think this might work. Let's see. So move big box. Moving big box. And if big box got called, move big box got called, we are going up or down. We should pass direction too. Okay. So let's get the next first. Be pretty much the same. So what's going on here? And if the next one equals this, wait, what? Oh dang. Oh yeah, because it's two pieces. This will be next one. And this will be next two, I guess. If next one equals that, or next two equals that, then return false. If next one equals the left side of a box, then I have to move that big box. So I just say and how did that go, kind of? If next one and two are periods, we'll say that first. I don't think you can do that. Next one is a period. Oh, and next two is a period, or if next one is period, next two is a period, then grid, next J1 equals grid I1, J1. Grid next I2, next J2 equals grid I2, J2, and then grid I1, J1 equals a period I2, J2 equals a period. Return true. If we'll say if next one equals this guy, then we know we have to and move big box oh crap. Oh, this depends. No. It's gonna be left either way. The big box is gonna be the next I. Put a column over to the left, even if it's down. And if it's this, then that's where the big box is going to be. I don't know, this doesn't seem right at all. Let's see. Oh, we still gotta inflate our grid. What in the world? Oh. Big grid. And this is gonna take some data, and it's going to be separated by new lines. Dot split by new lines. And we're going to map each one of these to an array. We're going to map each one of these lines to, first let's replace all let's see what it said, all of these with that. Replace all of those with these. And we're going to replace all of the periods with a double period. And replace all the ats with that. And that's going to give us a string back. And we're going to say, well, let's just map that to a character array. Okay, that should give us a big grid. See if it works. Grid is going to equal big grid map data. Let's print that out. Oh, that does not look right at all. Okay, so I need to escape some of these characters, I think. So let's look that up. I can't remember. Give me a cheat sheet. Come on. Come on, Dave. Okay. I don't think any of them are special. Oh, well, that should be fine. I think the second part's just a string. Oh, the period needs to be escaped. No, not these. What about the at? No. Okay. Let's see what that looks like. Okay, that looks good. And what about after moving? It should look like that. Let's see if it worked. Or did it get just all screwed up? We're gonna find out. Let's double check that map actually. Looks good. Nice. Okay. So after we simulate the movements, nope. Yeah, our boxes kind of got screwed up. So something's not quite right in Move with Big Boxes. let's kill some bugs. Dang, somebody almost watched for 3 minutes. Okay, dude. So we got move with big boxes. Oh. Oh my gosh. This might actually be it. I hope so. No. No. So move with big boxes. The first thing we want to do is get the character that is in front of the... Well, this will be a robot in this case, or... Yeah. And if the next one is a wall, we're done. We're not doing anything. If we are going up or down, we need to be concerned with one box being in contact with two boxes. One to the left of it and one to the right of it. Okay. So if we're going up or down and the next character is the left side of a box, and the next character is the left side of a box, then we need to move that big box, and that big box is going to be the next I, next J, with next I, next J plus 1. It's going to be the, or if we're facing down, it's going to be the one ahead of it and to the right. If that box moves, then if that box moves, then we can move our robot forward. Or, yeah, in this case, it would be just a robot forward. Yeah. Yeah. Okay. Else if it's the right side of a box, then just like it's going to be front and left of us. And if it's able to move, if it moves, then move ourselves forward. Okay. If the next one is a dot, I think I should say else if here. Well, what if we're going up or down? Yeah. Else if I should say if move with big boxes next I next J. Do this. And then here I'll just say else if. If the next one's a period or move with big boxes the next one, then do our swap. I think that's literally the same thing. Nope, that might have fixed it. Chestnuts roasting on an open fire. It's not right though. Are we printing out after? Yeah. So something is not right. Something's not right. This is disgusting. So we gotta get our next guy. If it's a wall, we're done. If we're going up or down, move big box. If that big box moves, then we can move. Let's make sure that we're not let's do this. If it equals this or the other, then we have a problem that I'm not dealing with. Well, so let's see. If that's the case, yeah. Let's see if we're getting any womps. Okay, no womps, right? Whoa, whoa, whoa. Why does that look? Oh, that's not right. Wait. Yeah. That's no right. Okay, that's good. So we're always working with a robot here. No. It broke again. Well, the next one's either that or it's that. Otherwise, you're just gonna move it, right? That's right, yeah. So maybe it's something with move big box. Let's check it out here. So I1J1, I1J1, I2J2, I2J2. Yep. Next one, I1J1, next two, I2J2. If either one of those now this should only be called if we're going up or down. Good. So this is only called when we're going up or down. And if yeah, there's a case that I am missing. Yeah, if next one equals this and next two equals this and move big box then do all this junk. No. This is getting unruly. Let me take this small example that they do a walkthrough with. So this is the small guy. So we got our little guy here. Let's run that with the first sample and let's print out each iteration to see when it starts going wrong. Move with big boxes, and then we want to do printers dot print array grid. Starts off good. Okay. And we want lines up underneath those two. And then you, oh, yeah, screws up right there. So going up or down, screwing up. So let's see what exactly happens here. That's weird. Oh. Oh. So that's handled in here. So if we're going up, let's do this. It's getting very unruly. It's getting very dirty. If next equals, oh crap, hold on. No. Wait. So we were good to there, and when we moved that up, that's this right here. Sorry, that's this. And we say move big box, that one and that one. Okay. Right. So it screws up right here. And then in move big box, are we passing the right thing first of all? Yes. Yes. Okay. And then in move big box, yeah, you should do this first. You should absolutely be doing this part first. Nope, I still see some that are getting screwed up. So we go down there. And what in the heck? So when there's two there, you actually should be making two recursive calls. That's absolutely right. And move big box. Oh, we're only doing it for next one. Oh my gosh. Oh, now. Oh, crap. So the next one. No, not on this one. You only need one call for this one. So that part's fine. But here, there is the case where it's like this. And this is where it gets real weird, because I can't try to move. They both have to be, they both have to move. Kind of have to do something weird here. So if we got two boxes in front of us, then we need to do left moves. Let's do this. Left moves. Don't actually recur here. So that's the left box. That's the right box. Crap. Oh, crap. Oh, because if you do that... Oh, dang, this one's tricky. Because if I recur and only one box moves and the other one doesn't, I would have to like bring that box back. So that's not gonna work. Dang. Also, yeah. So, let's just do this for just a second. If left moves and right moves. This is not gonna do what I want, but what does it do? Let's see. Does he push at least? No, 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 no. So they should both be pushing right there, at least, right? Hey. Something didn't work. What? Why didn't that print? Huh? So we're on this big box. What in the heck? Let's go. Oh, you know what? No, I don't know what. So we should be hitting this. Should be hitting that right before trying to move that big box, which we are. Right here. Right there. And then we move it and screw it up. And we say move big box. And we say yeah, and the one to the left of it. So let's print those out real quick just to double check. Yeah, let's print out next. And then let's print out grid. Next I. Next J minus 1. Oh, what? How are they backwards like that? Oh, because I printed them backwards. I'm putting them backwards in left then right, brother. Dang. Still not handling something right, though. Okay, let's see if at least that movement works. No. But I'm probably not doing something right down here. Yeah. Like this needs to go before. And this is supposed to be a plus. And that part's right. No. See how that one moved up too far? I don't know why that one went all the way up there. So it should have just stopped right here. So let's go to that. Okay. And then once we're down here and move big box, we should be hitting this case right here. Which we are. So we're hitting that case. So actually that box is moving, but this one gets left behind. So when this happens, oh, it's supposed to be 2. And we're also not even checking like all the next basically have to do next 2 is that. Oh wait. Well, yeah, if the one to the right is this. Wait, what the heck am I doing? You actually don't need that case. If next 2 is that, then move it, and it's 1 to the right. This is getting ridiculous. And then, right? Yeah, that part stays the same, I think. Okay, see, this is where I knew I'd have problems. Because I'm recurring. So, up to here good. But this part, it's when I have 2 boxes right there. You should make a new grid. Yeah, that's what I'll do. So I'll shit. Just overload this whole thing. Oh my gosh. And this is gonna take a temp grid. I'll just call it grid right here, it's fine. Yeah. And then so do I not have like a copy function? Okay. So we're going to make a copy of that array. Equals. Copy the grid. Pass the temp. And if that happens, then move both of them first. So you don't need this part or this part. And you don't need this. Okay. Maybe. Okay, kind of. Something happens right there, though. So it's like one step further. And then same thing here. So now we're here. Oh man, it's been 2 hours. Oh my gosh. I'm gonna finish this tonight. I don't care. So I'm making this happen. Then I'm making this happen. And then when I go up again for some reason. So yeah, we're hitting that. We're hitting that condition. Huh. Oh, I should be... using the one that I'm in right here. Dang it, dude. We move it. And then right here, we're getting on this condition here. And so we say move big box. We say if move big box. And here's move big box. And the condition it should be hitting is this one. So we make a temp array. And we see if we can move Big box with the temp array. Oh crap. These should all be temp, or with the grid. Because this is just for like temp. This is for moving without actually editing the thing. Okay. Okay. I may have done something. Nope, it's still broken. So why is it returning true? It sure is, right? J1, J2, J2. Yeah, I say no, but then it moves anyway. So which one of these is not supposed to be moving? Mm-hmm. And so right moves, let's point out these left moves. Right moves, they're obviously both coming out as true when they shouldn't be. I just gotta oh, no. Oh, right here they are, yeah. So right here they should not be coming out as true. So and then we move to big boxes. So why is right coming out as true? Let's follow that. Right moves. So let's go there. And I should totally be hitting this. Should totally be hitting that. Something's weird. Is it right here, maybe? Wait. Let's do this. And let's do this real quick. I just need to see where I'm at. And here, no. Here we don't move, apparently. But then it gets moved right here. So we move. Wait, what? Okay, wait. Yeah. But when we get here, we shouldn't be moving. But we are somehow. So I think that's going to be right here. Or it's actually right here. Ah. Wait, what am I doing? What am I doing? I should be looking in here when it's this. Yep, there. No. Yeah, we should be moving that box. And then when we move that box, move big box. So we go to move big box. And we hit this case, and Am I gonna have to come back to this tomorrow? Yeah. I'll probably watch some people on YouTube. Maybe I might hop on in a little bit. I feel like I'm missing something. Oh yeah. Sweet. Populated my database. Nice. It's beer. Cool. Very sweet. Alright. Yeah, I'll get on later. I can't figure out part 2 right now, and I've just kind of not been making progress, so I'll be back.